Here we go. All right. Today is Do a Grouch a Favor Day. I was like, this is the cutest thing ever. I don't know if y'all remember the Grouch from Sesame Street, but Oscar the Grouch, apparently today's his day. So it's Do a Grouch a Favor. So you're supposed to think of someone in your, you're supposed to think of someone for in your life who is a grouch, and then you're supposed to do something nice for them. Let me check this chat really fast. Melissa, I think you were working on 26 today. I think that's what the goal was. Sorry, yeah, you can sign off, Melissa. All right. So here's my question of the day. What does Oscar the Grouch do when the trash collector comes? Like, he lives in a trash can, right? So like, what does he do when the trash collector comes? That's my first question. And then my second question is also, he's lived in a metal trash can for 30 years. Like, how does he avoid rust? Like, you really got to ask yourself, like, must be taking excellent care of his trash can because it's not rusting. I know, what a legend. I'm like so interested by this idea. I had lots of ideas. Also, like, what does he do when like a really bad, you know how sometimes when the weather comes and it's terrible and the trash cans like end up on the ground, right? They end up on the ground. Like, how does Oscar's trash can not end up on the ground in like a hurricane? Also, does he get wet? I don't know. I spent a lot of time thinking about Oscar the Grouch yesterday. So very interesting. His skin is probably like a magic eraser, so he stays clean. Oh, interesting. He's built different. Yeah, I don't know. Kind of wild. Anyways, he stays clean. So today is Do a Grouch a Favor. Think of a grouch in your life. Think about how you can make them happy, and then make it happen. Gali is hitting us with the attendance chat. So if you need that, we'll do that. And then let's jump in, y'all. So I have 3 announcements for us. One is a note about assignments that I realized I've never really told you. One is an announcement about a mini quiz, and one is the raise hand feature. So my first one is a note. I realized when I was looking at one of y'all's like comments on your assignment that I've never really explained this part of our work together. So I just wanted to like give you a heads up. So I always make the homework first, and then I try to create notes from the problems that are on the assignment, okay? So what that means is like I create the assignment, I make notes that like match the assignment. So for part 1, like any of those problems in part 1 where it's generally just like problems, those should be pretty close to exactly what the notes are. So if you're finding that first part is like extremely different from the notes, that would be a good time to like text me or send me an email, like, Miss, what the heck? Why is part 1 like so weird? And why does it not look like the notes at all? Because those problems, like I literally just take those problems and change the numbers for the notes. So I want to make sure that we like really understand that part. So if part 1 is ever feeling really crazy, please let me know. Part 2 or part 3, depending on the lesson, I try to make you think outside of the box. So often the questions are more challenging, and you might not know if you got them correct or if you got them wrong. And that is actually on purpose. That's because this class is going to be our AP Calculus class next year. I'm very excited for you. And I think that you will do an amazing job in that class. But in AP, there are going to be a lot of times where you have no idea if you are right or wrong, right? Like you'll just be like, well, I got to try something, so I'm going to try, right? And so we're really working on our perseverance, because in AP Calculus is usually the first time that because we're like really good math students, AP Calculus is sometimes the first time when students like really struggle to learn math, right? You've been good at math your whole life. And so I want you to like have experience with that idea of like, oh, I might not know what the correct answer is, and I might just have to commit to an answer that is the best that I can possibly do, right? To put this in perspective, to pass the AP exam for calculus, you only have to get 35% of the questions right. 35% for AP calculus in order to pass. I think in order to get a 4 or 5, it's like 40, 45%. of the questions correct. So you don't even have to get half, you can get half of the questions wrong and still get a 5 on the exam. So that is why I want you, sometimes I want you to feel like it's a little bit of a struggle. That is the goal. That is my hope. Okay. So if you've been feeling like that on part 2 or part 3 of the last few assignments, that is okay. That's on purpose. That doesn't mean I won't help you. So please still reach out via text message, as many of you all have done, or via email. And I'm happy to let you know what's going on there. Okay. So just a note, some like behind the scenes of what Ms. Mack is thinking about when I'm creating your assignment. Okay. My second announcement is that we are going to have a mini quiz on Thursday. It will be best if you are here in class. If you cannot make it on Thursday, I'll have an alternate assignment for you. But I do want to make sure that we are just like putting together some of the things. We're getting to the end of our exponentials and logarithms unit, right? So we're going to do our last lesson on exponentials and logarithms today. And then on Thursday, it'll be sort of like a review and a mini quiz. I say mini quiz because it's not going to destroy your grade, I promise. And I just want to make sure that we're like really thinking through these different things that we've learned, and we're not just learning like a pocket of this and a pocket of that. We want to make sure that we're working with those skills individually. So that is our mini quiz on Thursday. Are there any questions? Let me pause there. Are there any questions about the assignment note or about the quiz on Thursday? You can put your question in the chat. Or if you don't have any questions, you can put no in the chat. That's fine too. Just lets me know that you're there. Feel free to come off mute if you'd like. All right. No one's listening to me. Thank you, Melissa. Okay. It looks like we are good. Cool. Okay, as we were talking about on last Thursday, I would love to use a feature called the raise hand feature. So I'm going to show you how to do it. There are maybe 3 ways. So the first way is in your participants window. If you click participants along the bottom, you may have a button that says raise hand. If you have that, go ahead and press that raise hand button now. Thank you, Kaylin. You can leave it raised. Don't press lower yet. If you have that button, awesome. You may have a reactions button on the bottom, right? You may have a reactions button on the bottom. If you have that reactions button, you might have something that says raise hand. Go ahead and try it. Go ahead and try it. Awesome. And then if you don't have either of these, there is actually a keyboard shortcut, right? Keyboard shortcut, which is you press the Alt. If you're on Windows, you're going to press Alt and Y at the same time. And if you're on the Mac, you're going to press Option Y at the same time. Go ahead and do that. Amazing. Okay, you can go ahead and lower your hands. You're going to lower it by pressing the same button. Great job. Awesome. Go ahead and lower your hand at this time. Awesome. Caitlin and Brandon, you can put your hand down. Amazing. Okay, great. I think we all found it. Was there anyone who wasn't able to raise their hand during that time? So you have the Alt Y or Option Y option as well if you can't find the button. I looked it up in case you didn't have one of these. I was like, there must be a way. So keyboard shortcut. Okay, so here's what I would like to do. So we are going to be done with our announcements here in a moment. We're going to take notes and assignment. If you would like to do the online version, right? So if you want to do team video today, I have a breakout room that is already operating. So I'm going to have to put you manually into a quiet space, which I'm happy to do. So if you want to go to team video, please go ahead and type team video in the chat right now, and I will pop you into a breakout room to do that. So if you would like to do team video, you're typing team video into the chat. I see you, thank you. while I am moving over this share, I will pop you in there. Thank you, everyone. And then once you see that breakout room, you can go ahead and pop into that quiet space. Melissa, I got you. Marissa, I got you. Sada E, I got you. Anybody else want to do team video today? Everybody's good to be with me? Oh, Kayla, I got you. Go ahead. Anybody else? Awesome. I'm going to switch over my notes. You can go ahead and grab your paper. Let me know how much time do we need. Are we ready to go? You got a piece of paper in front of you as I switch over my share screen. If you need that 2 to 3 minutes, take it now. Take it now as we're getting started. If you need that 1 minute, take it now. Not algebra, let's go to pre-calc. We don't need the assignment, we need the notes. I should erase them. All right, friends. Okay, as we were practicing, actually, I'm gonna respect our time. I'm gonna give us 20 more seconds for those of us who need that 1 minute. If you're already ready, you can go ahead and title it. We're doing solving exponential equations with logs. All right. Okay, I think I'm giving you your 1 minute. Let me go ahead and pause. If you're my human who needs 2 to 3 minutes, that is okay. All right, we have our title, Solving Exponential Equations with Logs. I would love to do the same thing that we did on Thursday, which is if you are willing to be called on, if you could go ahead and press that raise hand button at this time. So if you're willing to be called on at some point today, go ahead and press that raise hand button. If you're able to come off mute, go ahead and put that raise hand. I'll rely on you when I need some extra support here. Thanks, Mia. Thanks, Devin. Thank you, Christine. So if you're able to come off mute, go ahead and press that raise button. Thanks, Jimmy. Thanks, Eric. Thanks, Walter. Thanks, Axel. All right. Cool. So if you're able to come off mute, go ahead and press that raise the hand button. No hard feelings if you can, that's okay. All right. So today we're going to solve exponential equations with logs. In the past, we have done solving exponential equations with, we've done it with common bases, right? So we've done that common basis. Today we're going to learn to solve them with logs because not everything can have a common base. Devin Z, can you read our 3 steps for today, please?
We're gonna isolate, use a log on both sides, and then solve.
Yes, absolutely. Thank you, Devin. All right, so we're going to isolate. We're going to get the exponential by itself. We're going to use a log on both sides. That'll be our new step for today. And then we'll solve it as we are normally able to solve. So we're going to start with this equation here, 3 plus 2 to the power of 3 minus 2x equals 11. And I have this part is my exponential equation here. This is my exponential expression, right? I know that that's true because the variable is in the exponent. And I have this 3 plus here. Mia, how can I isolate the 2 with the exponent? How could I get rid of the 3?
You subtract 3 from both sides. So that leaves you with 2 to the power of 3 minus 2x equals 9.
9? Are you sure, Mia?
My bad,
8.
not 9.
Yeah.
Yeah.
That's okay. No problem. No problem. Thank you. Perfect. So we have 11 minus 3 is 8. We have the 2 to the power of 3 minus 2x, as Mia said. And now we might be tempted, right? Remember I said that we learned another way. We learned that we could change the 8 into 2 to the third, and then the exponents would be the same, right? So that is one way that we could do this, right? One way that we could do this. However, today we're learning a new step, right? We're learning a new step. Here is what our new step is going to be. We are going to say, okay, if I know that I have a base of 2, then if I use log base 2 on this side, and of course, what we do on one side, we have to do on the other. What will that mean? I'm throwing this to everyone. What will that mean about the exponent? Where will our exponent go if I put a logarithm here? Feel free to come off mute or put it in the chat. Yes, Fatima, thank you for your chat. The exponent will move to the front. Remember that rule with logarithms? The exponent is moving to the front. So what this would mean is 3 minus 2x is being multiplied times log base 2 of 2. Wait for my live to catch up there. What is log base 2 of 2? Anyone remember? What happens when I have the log base of the same number? Yeah, Eric, it's just 1, right? It's just 1. These are really just like becoming 1. This is 1. So I don't need to write that down, right? I'm basically canceling out log base 2 of 2, and I'm left with just this exponent here for my problem. So in order to get rid of the base here, I'm going to use log base of that same number. That will move the exponent out in front. These will cancel into 1, and I'll be left with 3 minus 2x. All right, let's see what happened on the other side. Christine, can you talk to us about log base 2 of 8? Log base 2 of 8. Do you know what that number is?
It's the other side.
Yeah, it's the other side. Yeah. Do you know how to calculate this number?
Don't you go to decimals? Wouldn't it be 3?
Yes. Okay, you said go to decimals to use my calculator, but then you knew it was 3. Christine, did you do 3 in your head?
Well, yeah, because 2 to the power of 3 is 8.
Yes, absolutely. Okay, so we have 2 options. We can, if we are like Christine and we know 2 to the power of 3 is 8, right? We can say, okay, this is 3. If we are less confident with calculating logarithms in our head, which is 125% million, 125 million% off, totally fine, we can use our calculator, right? We can use our calculator. I'm going to let my iPad catch up to this lag here this morning. My apologies, y'all. All right, so we have log, still lagging, 1 moment. All right, so in here, I'm going to go ahead and press this functions button. I'm going to go to log base, put a 2 here, an 8 there, and I can see that there will be a 3. This is, hold on 1 moment. Yes, Devin, I absolutely can. Let me pause my share real fast and reshare here. My lagging is out of control in this moment. All right, so we have log base 2 of 8, right? We could put it in this way. Devin asked a great question, which was, can we do it if we have a calculator? Let me look at his specific question here. Can you do a log with a base that isn't 10 into a physical calculator? Yes, you can. So if you have a yellow calculator or a TI-83 or 84, So it's probably not yellow since these are just the class ones. You're gonna go to math, and then you're gonna go down to A, which is log base. And it will actually let you, I don't know if you can see this, it will actually let you put in your log base here. Okay. If you don't have a calculator, that's like this one. If you are just working with Decimal Scientific or something like that, you can put log, just a regular log of 8 divided by the regular log of 2, and you'll get that same number 3, right? The same number 3. So you put the big number on the top and the base number on the bottom, and it will tell you what that number is. Devin, does that answer your question? You're welcome. Awesome. Cool. Okay, so let's return to our problem. Let's just reevaluate where we're at. Number 1, we isolated, right? And Mia absolutely helped us isolate that by itself. Number 2, we used a log on both sides, right? So here in purple, we used the log on both sides, and that got us to our exponent on the outside here. Our log canceled, and we are left with this problem here. And then we have our third step, which is to solve it, which I'm sure many of you have already done. Can someone come off mute and tell me, how can I solve this problem? How could I finish solving for X? I'll go with Jimmy. Jimmy, come off mute and talk to me.
You subtract 3, and then you'll get 0.
What does
And
it
then-
equal?
It equals to negative 2x.
Good. Okay.
And then you divide negative 2x.
Do I
And-
divide the X or just negative 2?
Oh, negative 2.
Okay.
And then x equals 0.
X equals 0. Thanks, Jimmy. So we have X equals 0, just like that. I can check my work by plugging it back in, right? It is possible to get extraneous solutions here. So I am going to check by plugging in my X at 0, just like we've done in the past. So we get 3 plus 2 to the power of 3 minus 0 would be 3. 3 plus 8 would be 11. We're seeing that 11 that we should have here. So we have our correct answer there. So our step one was isolating. Step 2 was taking the log of both sides. Step 3, solving. I'm gonna go ahead and send out this poll. How are we feeling? Took us a minute to get there this morning, but how are we feeling about this problem that we've done so far? If you are a 2 or a 3, if you're a 2 or a 3, if you could private message me the step where you think you got confused. If you're a 2 or a 3, private message me the step 1, step 2, step 3, where you got confused. Thank you for that private message. All right. Okay. Thank you for those private messages. Yes, I have a great question to answer here. One question was, why did you cross out the 2 as well? Like, why did this go away? And it's because the base is the same. So because like log base 2 of 2, that's going to equal 1, right? So this equals 1. So log base 2 of 2 equals 1 because 2 to the power of what gives you 2? It'd be 1. So this whole thing turns into just the number 1, and 1 times this over here is just going to give you 3 minus 2x. Right, so because the base is the same as the number, we can cancel out both of them. So what happens if it's not a 2? So if this is a 3 as my base, I'd put log 3. If this was a 10 as my base, I'd put log base 10. If this was, like if I had 16 to the power of x, I would put log base 16. And these would cancel, leave me with just x. if I had if I had 8 to the power of 2x minus 1, I would put log base 8. And these would cancel and leave me with 2x minus 1. Does that make sense? Yeah, so if it doesn't, so this has a base, so when we have 16 to the power of x, this is the base of this exponent right here. And so when we use log base 16, then these would cancel. If we just wrote log 16, that would be log base 10. These would not cancel. We wouldn't be able to do that, right? So we have to use the base of the number that is here. It's a great question, Kimbo. Cool. Okay, let's try this one here. So we're going to do the exact same type of problem, but use our natural log. So here, our first step is to isolate. We need to get e to the power of x minus 1 by itself. Axel, can you talk to us about how we can get this by itself? How can we isolate it?
We have to subtract 1 first on both sides, and we get 3e of with the exponent of x minus 1 equals 9.
Perfect. And then
we divide by 3.
Great.
On both sides, and we get e x minus 1 over equals 3.
Perfect. Thank you so much. All right, so we have e to the power of x minus 1 equals 3, right? What log, I could put like log e here, right? But there is a fancy kind of log that I could put there. Gali, did you have a question you wanted to answer now, or are you just ready to come off mute?
Oh, no, I was just ready.
Great, you're ready. Sweet. Do you know, Galilee, what kind of log I could put here in order to cancel with the e?
I was actually just gonna go the simple way and put the log e to cancel it out.
Yeah, so you could put log base e like this. The real way of writing that is just writing, like the shortcut way is just writing natural log ln. Yeah, Fatima, we can use the natural log because the natural log comes with that e down there, and then we don't have to worry about anything else. We can just use natural log e. Thanks, Gali, and thanks, Fatima, as well. So what I do on one side, I also have to do on the other. So I'm canceling the e's. The natural log of e is just 1. So I would have 1 times the x minus 1 is dropping out equals the natural log of 3. I can go to my calculator and I can find the natural log of 3 is this decimal. But for my purposes right now, I'm actually just going to leave it as the natural log of 3, like this. Right? I want to now solve. Right? I want to solve it. So I'm going to add 1 on both sides. It's going to leave me with x equals the natural log of 3 plus 1. This is the exact answer. You might remember this from when we were using radicals. This is my exact answer, right? If I wanted to get an approximate version, a decimal approximation, I'm just going to go ahead and write the natural log of 3 plus 1 in my calculator, and I get 2.099. I'm going to round here. Use 3 decimal places and round. This is my approximate answer. Both of those answers are correct. You might use them in different situations based on what the question asks or what the answer key looks like. So for this one here, this is my exact version and this is my approximate version. If they're asking for exact, they just don't want you to go to decimals. So they want you to leave it in the natural log in the natural log or in the log after that. Okay. All right. All right, let's try one more. Actually, let me ask you this one more time. How are you feeling based on that one? Based on that one, how are we feeling? Cool. You've already filled out the things. Go ahead and write down this problem. This will be our next problem, our last problem for today. All right. Looks like we are mostly 4s and 5s, a few 3s, so feel free to keep asking this question. Thank you for being honest. All right. So here on this problem, I have exponential expressions on both sides, right? I have an exponent with a variable here, an exponent with a variable here. I need to get rid of one of those things, right? I'm going to get rid of one at a time. So what I'm going to do, if I want to get rid of the 2, right? If I want to get rid of the 2, Walter, what could I put here if I want to get rid of the 2? Log base what to get rid of the 2?
Log base 2.
Log base 2, perfect. Log base 2 to get rid of the 2 here. And then it would be tempting to do log base 5, but since I did log base 2 on this side, I have to do log base 2 on this side. So those are not going to cancel, right? They're not going to cancel. We're going to find out their number. So here's what will happen. Log base 2 and 2 will cancel and leave me with x plus 2 here. On this side, my log base 2 of 5, I'm going to do that part of my calculator. And in the meantime, the exponent is moving out in front. The exponent is moving out in front. So I would have x minus 3 times log base 2 of 5, right? Log base 2 of 5. I'm going to go ahead and calculate this because this is a number, right? Log base 2. So I'm going to go to my calculator. I'm going to go to functions. Yes, Galilee. I'm going to put 2 here, 5 here. I'm going to leave this in my calculator, but I'm going to use the decimal approximation 23219. I know that there are more numbers. I'm going to use at least 4 of them, 4 decimals, because I want it to be as exact as possible. And then I have that number is still times x minus 3. This number applies to both of these items here, x and negative 3. I'm going to go ahead and distribute into each piece. It's going to get a little cranky around here. 23219 times x minus, and I want to do 3 times this number. So I'm just going to go over here and put times 3 to get my decimal approximation of 6.96578, right? I have more numbers here. Is equal to x plus 2. Like that. Now, what we have done is created a problem, a linear equation. It just has x's, no x squared or anything. It just has x's in it. It has decimals, yes, but it's not too crazy. So I'm going to go ahead and subtract x on both sides. It's going to cancel here. And I'm going to add 6.96578 on this side. 6.965, et cetera, et cetera. This number right here. Right. So now I'm going to go ahead and just say, okay, I'm going to add 2 to this number. I'm doing 2 plus this number. I should get 8.9657, blah, 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 right? Equals, and then here I have 2.3x minus 1x would be 1.3219x, like that. What would my last step be? What would that last step be? Eric, what can I do next? What would my last step be?
Just divide both by 1.3219.
Mm-hmm. Perfect. So now, honestly, if I have this number already in my calculator, I'm going to put parentheses again so that it keeps everything inside of there. And I'm going to do divide by, and then 1.3219. And I get x equals 6.782. Once I have my answer, I'm going to use 3 decimal places. I want to use as many decimal places as possible throughout the problem so that I don't have a rounding problem. But at the end, I'm going to use 3 decimal places to show my answer. 3 decimal places. A little wild. Right. A little wild, but not altogether too different than what we have been doing. I'm going to go ahead and launch this one more time. Tell me how you're feeling about this after this last problem. Yes, I absolutely can. Marley, it was 2.3. There were this many x's. And I wanted to get this, I wanted to move this 1x to the other side. So I did 2.31 or 2.32 minus that 1, and I got 1.32. Like that. And then that was how many x's we had. So we divided by that number to get this number away from x to find out how much one. Sweet. Good question, Mark. All right. Looking like we are set on mostly fours. Appreciate you. Thank you so much. All right. There is a way to do the exact version of this. It is a long process. I filmed the entire thing on video. If you are like super interested and you want to know how to find the exact version, you can check out the video. But for today's purposes, we're just going to be working with the decimal equivalent. Okay. For your assignment today, you're going to do 8 of these problems. These are the ones that should look exactly like the notes, right? So 8 of these problems here, your answer keys here, the answer keys back for those of you who were asking for the answer key to come back. So I brought it back. And then in part 2, you're just doing an explanation, right? You're working your way through an explanation. You can use words, or you can use you can write it on your paper and take a picture. If you would prefer to use sentences or bullet points, you're welcome to. And then in part 3, this is like the more challenging section. You're going to solve this problem using common bases, that method that we learned in 22. And then you're going to solve the same problem using logs, right? So you should get the same answer for both of these, one method with common bases, one method with logs. And then these 2 questions are going to ask you about when you should use each method, right? So when should you use common bases? When should you use logs? Okay. From there, you are done. You have a note about the mini quiz that's happening. And then there is extra credit if you are so inclined. You can work on the extra credit. Don't forget that we have office hours from 10:30 right now until 11:20. And then we also have office hours from 11:20 until noon. So if you, depending on when your Spanish class is, you can come whenever best fits your schedule. But we will be here from 10:30 to noon today. And Ms. Yamanaka and I can support you on these problems. Okay. If you have any questions, feel free to stick around. Otherwise, it is almost 10:30, so I will let you go, and I will talk to you on Thursday. Thanks, y'all. Thank you. Goodbye. Bye, Miriam. Adios. Thank you to my raise hand people. Appreciate you today. Bye, Mia. Have a good day. Bye, Diana. Galdi, so glad you're back.
Miss, I'm sorry, it's not about math, but just a quick update for the pen pals. I sent you an email about it. I know you're busy, but it's tomorrow and I need a reply by today. So whenever you can look at it, I would greatly appreciate it.
Yeah, I just haven't checked my email yet. Can you just tell me what it is?
Yeah, so my pen pal is Alejandro, but I also happen to have another pen pal.